My name is John Demos. I'm the author of Getting Started with Neurofeedback. I'm the Director of Neurofeedback of Southern Vermont, an organization that represents the Biofeedback Certification International Alliance. In order to become board certified, you need to take the BCIA curriculum. Module 1 of this curriculum is an orientation to neurofeedback. It takes approximately 4 hours. This is a very brief review of Module 1. It covers such topics as what is biofeedback, how is the EEG defined, what constitutes a normal or average EEG, and how can statistics be used in measurement, diagnosis, and training. 2 key words that define biofeedback are self-regulation and operant conditioning. What does EEG biofeedback measure? It measures the electroencephalogram, and it divides it into microvolts, frequency, variability, coherence, and phase. How do we measure it? We measure the EEG, or the electroencephalogram, with amplifiers, which measure the whole EEG signal, and then filters are applied to measure portions of that signal, or ranges. Professionals focus on the raw EEG, or whole signal, first, and the filtered EEG second. This is an example of the raw EEG and specific morphology. This is the morphology of a theta wave, and here is the morphology of the sinusoidal pattern morphology of alpha waves. And beneath this is the typical presentation of the filtered EEG. Frequency ranges may be associated with positive or negative attributes. So there is a morphology for theta, delta, alpha, and beta. Now delta may be associated with sleep, which is a good thing, or trauma, which is a negative thing. Theta may be associated with creativity, positive, distractibility, negative. Alpha with calmness, or mental fog, or being alert. Beta could be associated with being attentive or having anxiety. 2 concepts that are often used to determine normal and abnormal are under-aroused and over-aroused. Under-aroused means that the EEG shows a pattern of too much slowing, that is, theta is greater than beta. Over-aroused is just the opposite. The EEG has a pattern of fast wave activity, beta is greater than theta. So here's a compressed spectral array. There's from 0 to 32 hertz, and there's a time period of 40 seconds. And this watershed diagram shows that the theta, which is dark blue, is far greater than the beta. This client is under-aroused. This is a 10-year-old boy with an attention deficit disorder. On the other hand, this client is over-aroused, just the opposite. The beta is far greater than the theta. This client is anxious. They could have OCD. It's also possible that they could be the beta type of ADHD. Single wave measurements are made with 1 channel of EEG, and they can measure the EEG via frequency, amplitude, variability, or power ratio. Multiple wave measurements require more than 1 channel. There are 2 EEG waves here. There must be 2 channels of EEG activity. And because multiple wave measurements allow for comparisons, why the name of 3 of those comparisons are phase, coherence, and asymmetry. For example, with asymmetry, a left hemisphere alpha asymmetry means that there is more alpha in the left hemisphere, and such a client might be depressed or may have a learning disorder. Whereas a right hemisphere beta asymmetry may indicate that the client is anxious, impulsive, or agitated because the beta is greater in the right hemisphere when compared to the left hemisphere at homologous sites. How do we establish a normative pattern of EEG? We can use statistics. And statistics help us to determine a normative pattern by comparing our client with a database. Now, it's true that high-functioning individuals may have an EEG pattern that varies from plus or minus 1 standard deviation. However, for most of the clinical population, Z-score training, which relies on standard deviations and databases, can help most clients to align their EEG pattern with the database, which results in symptom reduction and enhanced cognitive performance. So here's a Gaussian curve, and it clearly shows that 68% of the population falls within plus or minus 1 standard deviation, which sometimes is called plus or minus 1 Z-score. What are our goals as neurofeedback providers? Assess for symptoms, match those symptoms with our current understanding of neurology, and then use brain maps to identify which EEG abnormalities fit our client's symptoms best. And that's where we put our electrodes. During our live webcast, we use a 4-channel Atlantis plus mini DZ caps and mini DZ database software to create symptom brain maps, EEG brain maps, in order to identify training sites of significance. So here's an example of a symptom brain map, and it went over this entire list of symptoms. You compared your client to this list of symptoms. If they had this symptom, then you check this off, and this part of the brain lights up. Those are areas of the brain that you might put electrodes on, and you might train there. In this client, we hypothetically was depressed, and so there was a left hemisphere alpha asymmetry. Again, we might put our electrodes on that part of the scalp. Then we wanted to do an EEG assessment and make a brain map. And so we put on the mini DZ cap, we injected all the appropriate places, we lowered our impedance, and voila, we have a brain map. Now, DZ cap software arranges the data according to 4 age groups with eyes open and eyes closed. And you can see the areas of the brain that are greater than 2.5 standard deviation, and the right temporal lobe, the posterior cingulate gyrus, and the anterior portion of the cingulate gyrus. There's also a data page review, which helped us to appreciate that with this one client there was a left hemisphere alpha asymmetry signifying depression or a learning disorder. The theta to beta ratio was normal at the vertex or CZ, and there was no headache alerts. Then we were next ready to train ourselves or future clients with 4-channel Z-score training using the mini DZ cap. And when we use Z-score training, we could train with such metrics as frequency, amplitude, ratios, asymmetry, coherence, phase, and all of them relate to Z-score training. So our course outline for Module 1, which was an orientation to neurofeedback, we considered topics such as what is biofeedback, how is the EEG defined in metrics, what constitutes a normal or average EEG, and how can statistics be used in measurement, diagnosis, and training. The next module helps us to understand how the electrical activity of the brain is formed and how we can then measure the rhythmic pattern known as the EEG in a way that can be helpful in diagnosing and training our clients. So we invite you to look at Module 2 and to continue on with this review of the BCIA curriculum, Getting Started with Neurofeedback.